Welcome to week 6. This is the lab lecture for week 6, and what we're going to be talking about this week is continuing on with section 3 of the semester project. We're still in the data area of the energy audit report, and we're going to be looking at the computer simulation. Section 3, or the computer simulation section of an energy audit report, really has some key areas involved. There's first an explanation area. Now this is crucial. The building owner, operator, or a facility manager may grab this report, or this report may be handed on to other professionals. And there needs to be an initial explanation of what the carrier HAP program is and why we need it. So the first paragraph in this section describes what the carrier HAP program is and why we need it. The next major paragraph is describing what a load calculation is. In essence, we want to get across to the reader that it's meant to size the HVAC equipment. In a new building, this would be used to actually do the selection. In an existing building where we're doing an energy audit, this is done so we can take what the carrier program is predicting should be the size of the equipment with what's actually in the building. In this case, we know if something's oversized, undersized, is there a problem there? Frequently, oversized equipment has trouble with short cycling, a lot of increased maintenance. Undersized equipment runs all the time, and there's still comfort issues in the space. The third paragraph describes the second reason that you would do a carrier HAP program. This is the building simulation. It's used for two things. The first thing it does is once we add the utility costs, the actual utility billing from the building we're doing, we can run the carrier HAP program under simulation and get a cost of operation. What this allows us to do is actually compare with the real billing that we were given from the building owner and worked on in section 2. When we compare these two, we can get a feel for if our building simulation actually is close or accurately portraying what the building is doing. The second part of this is once we know we have a building that accurately represents the building in the field, we can do complex what-ifs, or multiple ECMs at a time, or ECMs that would be difficult to do with a manual method. And you guys should be sensitive to doing manual methods by now. So ECM, again, stands for Energy Conservation Measure. When I did the bonus review on the carrier HAP program, I went into the HVAC equipment and showed you where we can change efficiencies. It's really crucial that we use the carrier HAP program to do things like efficiency changes, because this equipment isn't running all the time. So the carrier program can actually take that into consideration, along with changing delta T's, changing solar loads, changing occupancy loads. It's really about the only way to do a really good detailed analysis on specific recommendations that we're going to make later on in the area, especially of mechanical equipment. Then we have a result area. The load calculation compares existing and load calculation results. In other words, this is what the carrier program came up with. This is what I'm seeing in the field. On the building simulation, it compares annual energy cost with simulation energy cost. So back to the load calculation, when I compare that, I really have a table of existing equipment, including their current heating size and cooling size, cooling in ton, heating in BTUs, and the carrier program will predict a a recommended sizing, and we plug that in. So we put cooling in tons, heating in BTUs, and we compare the two. If they're too far out of sync, this would generate recommendations for later on in the document. Under the building simulation side, again, that first phase is to compare annual energy cost with the simulation energy cost. This is to ensure that our simulation truly is working and we can feel comfortable about utilizing this file to predict what's happening in the building. And then again, which we talked about already, we want to include a percent annual component cost table and chart and a percent annual energy cost table and chart. This is like one-stop shopping of where key energy is being used. This is really important, especially the federal government when they're paying for an energy audit. This is something that they require in their energy audits. So the annual component cost, what percent of the energy usage is by what types of equipment or devices. Example, lighting 58%, HVAC 27%, other electric 15%. This is divided down as far as we have information for. So the other electric, depending on how we put it into the computer, can actually be subdivided even further than what it already is. This is what it looks like. That's the chart, the typical pie chart. There's the corresponding table that goes with that. Now, you want to make sure that your square footages, everything should line up in a energy audit document. Whenever you're putting something in, if you've already started mentioning square footage, like under the building description somewhere, this number better match what you've already talked about. If it doesn't, there's a problem. And those are problems that if they get all the way through and an owner picks it up or another professional picks it up, it has a tendency to cast poor light on the overall energy document. Here's the annual energy cost. Here's the pie table for it. Here's the corresponding, well, this is the table. The previous page had the chart. Again, I showed you how to get these in that bonus video. And again, it gives that square footage on the bottom that we want to make sure tallies up and works out right. Now in Lab 6, it's a 3-part lab, so you're should be getting used to this. So you're going to download the lab, which is part of an assignment. In part 1, you get to use your creative side. You're going to write a description area for what the Carrier HAP program is and why we use it. So there's actually 3 paragraphs that you have to write. Then you have to write, in the second paragraph, you have to write what a load calc is, why we use it, especially in an energy audit. In the third paragraph, you're going to have to write what a building simulation is, why we use it in an energy audit, etc. So part 1, you're going to do a little bit of writing. The lab actually has a form. You're going to write it right in a form. You should remember that this is a technical document. Technical documents, you don't use things like we, they, our, no pronouns. No pronouns. In part 2 of the lab, you're going to go back to the space input sheets that you were given way back in Lab 3. And now you're going to look for the HVAC equipment, which there's 7 different pieces of HVAC equipment, and you're going to fill in the table of what currently is existing. Then you're going to go to the Carrier program and run a load calc on each individual piece of equipment, and you're going to look at what the Carrier program is predicting the equipment size should be, and you're going to fill that in. Now, at this point in time, we're not going to write a recommendation. This is just a table filled out with the existing versus predicted, and this will generate recommendations for later on in the document. And then finally, part 3. You'll generate the 2 graphs and tables for artworks. So you're going to go to your utility billing last week. You're going to fill in the appropriate pieces of utility information into both the electric utility rate and the natural gas utility rate. You're going to go to the building and run a simulation. You're going to compare the total cost with the cost of the actual utility cost that you had calculated last week against what the carrier program's predicting. Then you're going to go in and you're going to grab both the pie charts and the tables and copy them into that form. When you're done with the form, filling out the written area that you did, the table that you filled out, and the graphs that you plugged in, you're going to save that file with your name introduced. You're going to attach it back in this assignment back to me for grading. And that should do it. This is the end of Lab Lecture 6. You now may proceed to Lab 6. We will see you next week.